be looking at graphing systems of equations. And the goal here is to solve systems of equations by using a graphing technique. So first thing we need to say is what is a system of equation? So what a system of equation is where you have multiple equations. You can have at least two, but more than one. All of the equations have to be true at the same time. A system of equations can have one solution, no solutions, or infinitely many. You're never going to have just two or just three, nothing like that. You either have no solutions, exactly one solution, or infinitely many. And here's an example of what a solution would look like to this system of equations. So this is your system of equations. So these are two equations that we want both of them to be true at the same time. So the goal is to find a solution where both of these are true. And we can verify that 2, 1 is a solution. So what that means is that x is equal to 2 and y is equal to 1. So let's plug in 2 and 1 into both these and make sure they work. So in our first equation, it says 3x minus y equals 5. So if I plug in x equals 2, plug in y equals 1, does that actually equal 5? Let's see, 6 minus 1, it does equal 5. So that is a solution to the first one. And now my second equation is x plus y equals 3. So let's plug in 2 and 1 and see what happens. So is 2 plus 1 equal to 3? And yeah, it is. So it's a solution to both. So that means that 2, 1 is a solution to this system of equations. What we're going to do before we start doing this algebraically is we're going to be solving these by graphing. So here's your first system of equations. We have y equals negative 1/2 x plus 3 and y equals 3/4 x minus 2. What I've done is I graphed the first equation. So this is y equals negative 1/2 x plus 3. You can see it has that y-intercept of 3 and a slope of negative 1/2. But then I'll also force x minus 2. What we see is that these two lines intersect at one point, and that point where they intersect is our solution. So the solution here is 4, 1, or we can write it as x equals 4, y equals 1. It's more customary to write it as this coordinate, so 4, 1. And you can verify that if you want. Plug in 4 for x in both equations and make sure you get the correct y value. Next, we'll find the solution to 6x minus 3y equals negative 9 and 2x plus 2y equals negative 6. So the way they're set up, it's kind of hard to graph them. So what we could do is rearrange them. So you can kind of do this on your own here, but if I were going to rearrange this and get y by itself, well, I would move the 9 over and the negative 3y to the other side, and then divide everything by 3. So I think I get y equals 2x plus 3 for my first one. And then for my second one, I'll do the same thing. And I believe on this one, I'll get y equals negative x minus 3. From there, you should be able to graph them, which I've done. So here are the two graphs of my equations. You can see that we have an intersection right here, and that looks like where x is negative 2 and y is negative 1. So my solution to this system of equations is negative 2, negative 1. And if you're wondering what I'm using to graph, I'm using Desmos graphing. So if you want to look that up, you're definitely allowed to use that. Then lastly, we'll find a solution to y equals 3/2 x minus 4 and y equals 3/2 x plus 1. So I've graphed both of these. And this is a picture that we get. Now what you see is that these graphs don't overlap. The lines don't cross at all. So when this happens, that means there's no solution. If the graphs don't intersect, then we have no solution to the system of equations.